Well, today we're going to talk about real line and interval. Let's review a little bit what we learned so far. We start talking about numbers, am I right? So recall that. We introduced numbers. We start talking about natural numbers. Denoted by n. We use set notation. We say that n is equal to, we open a curly bracket and we start listing the natural numbers like 1, 2, 3, and the rest of these numbers. As you remember, the smallest number in this set is 1, and the maximum number is usually denoted by infinity. But infinity is not an actual number. It's just representing the largest number. To represent natural numbers, we use number line. Okay, here you have number line, and since it's started at 1, so you're going to have 1, then 2, then 3, then 4, and the rest of the counting numbers or natural numbers. Their numbers on the right-hand side, they're getting larger and larger, and they go to positive infinity. Very well. As you remember, we have gaps between these numbers. There are gaps in between them. Then we say that, hey, natural numbers, they don't have 0. So let us add 0 and introduce a new system, which we call whole numbers. Whole numbers, remember, it was denoted by W. We only add one number to natural numbers to introduce a new system. 0, 1, 2, 3, and the rest of the counting numbers. On the real line, since we are adding 0, 0 forms a new representation or representative in this case. We have 0, then we have 1, then we have 2, 3, 4, 5, and the rest of the numbers, and the maximum, the largest number, is represented by infinity. Very well. As you remember, we say that, hey, these two sets, they have no negative numbers. Let us add negative numbers and represent a new system, which we call integers. Integers are denoted by I or Z. So I, bolded letter I, or Z, bolded letter Z. They are both representing natural numbers along with 0, along with sign numbers. So we call them integers. So starting from left, the smallest number, we have no idea what's the smallest number on the left-hand side. What is the smallest negative number? We only use some of the negative numbers to say that, hey, on the left-hand side, we are getting to a smaller numbers. -3, -2, -1, 0, 1, 2, 3. Well, so we are adding more numbers in this system. On the left-hand side, it reaches to negative infinity, and on the right-hand side, it reaches to positive infinity. It has 0, so let us put 0. In the middle, some positive numbers, 1, 2, 3, 4, and on the left-hand side, some negative numbers, -1, -2, -3, -4, and so on. Again, we still have gaps between these numbers. We cannot take a half. A half is not an integer. So I expect you to ask, then what should I do with, for example, fractions? 1 divided by 2. I don't know, 5 divided by 9. What should I do with, for example, decimals? So in this case, we're going to introduce a new system. We're going to call it rational numbers or fractions. Rationals. Rationals is denoted by Q. Q is defined this way. Remember that we cannot list all fractions. So instead of roster list, we're going to use set definition of numbers. So since we cannot list all fractions, it's impossible. We use a set definition for Q. Okay, set definition for Q. We're going to say that, hey, Q or rationals is the set of all fractions, the set of all A divided by B's, such that, with the condition that A and B are integers, and the denominator is not 0. Another form representing is the set of all fractions, A over B, such that A comma B, A and B belongs to Z. So this symbol that you see here is belong to, and B is not 0. So this symbol here, A and B are integers, so A and B belongs to. This is a mathematical symbol that you're representing. They read belong to. So again, since it's impossible to list all fractions, we're going to switch to set definition of Q. We read it as Q is the set of all fractions such that, so Q is, this is the set of all fractions such that the numerator and the denominator, A and B, numerator and denominator are integers, and the denominator is never 0. Well, after defining rationals, I expect you to ask, what should I do with radical 2? Well, okay. What should I do with, for example, radical 3, square root of 3? What should I do with pi? What about Napier numbers? Are those rationals? Those are not rationals. We call them irrationals. So irrationals, which denoted by Q complement. Q complement. The complement of rationals are called irrationals. Q complement, they include square root of 2, for example, square root of 3, they include pi, they include Napier number, and so on. So we have another name for the set of non-rationals or irrationals. We call it QC or Q complement irrationals. Well, still, if you graph these two, you're going to have some gaps. But if you graph them together, you're going to have the whole real line. So we say that real numbers, which denoted by R, bolded letter R, is Q for rationals union QC. This U here is a mathematic operator that we call union. What do I mean by that? It means that I'm taking all fractions. I'm taking all square roots, pi, Napier number, and all of those numbers, put them all together in one set, and I call it R, or real numbers. So if I ask you to graph this, what are you going to do? You're going to say, hey, it includes all numbers on the horizontal line. All numbers on the horizontal line. Here we go. From negative infinity to positive infinity, and you're going to shade all a real line. We're going to shade it all. All of these are real numbers. All of these are real numbers. Well, we're going to use 0, 1, -1, 2, -2 for scaling's sake. So this is your real line, and we're using 0, 1, 2, 3 positive numbers, -1, -2, -3, and the rest of the negative numbers to represent the scaling. So again, when you're working with R or real line, all numbers are included. There is no gap between these numbers, no gap. Again, remember, natural numbers, you have gaps between numbers. Only 1, 2, 3, 4, 5, 6, 7, 8, and the rest of them are taken. For whole numbers, you only have 0, you only have 1, you only have 2, you only have 3. There are gaps in between. You do not have negative numbers. When it comes to integers, well, I have 0, 1, 2, 3, 4, 5, 6, 7, 8, and the rest of them. And also I have some negative numbers, -1, -2, -3, -4, but there are still gaps in between these. And then we moved on and defined more complicated numbers like rationals, then irrationals. And then we say that, hey, let us take all rationals and irrationals together and build this real line. When you're talking about x-axis and y-axis, those axes are both real lines.